Hello friends, today's question. A wedge of mass 4m lies on a frictionless plane. A particle of mass m approaches the wedge with the speed v. There is no friction between the particle and plane or between the particle and the wedge. The maximum height climbed by the particle on the wedge is given by. So we have a wedge like this whose mass is given as 4m, and there is a particle of mass m and which approaches this wedge with the speed that is given as v. So as such there is no friction anywhere, so therefore we can say that this particle is going to climb up the inclined plane. Suppose this is the position at any time of mass m, and this is the wedge of mass 4m, and at this particular moment, because of this mass m, let us suppose it is moving with the velocity v prime, and this mass 4m is also going to move with the velocity v prime, and the height of the mass is suppose given as h. So we are supposed to find out the maximum height to which it climbs the wedge. We can say this is the initial position, and this is the final position. So in initial position, velocity of mass m is given as v, and in the final position, velocity of mass m is given as v prime, the velocity of wedge is 0, whereas velocity of wedge is equal to v prime, and there will be one extra parameter in this case of when the particle is along on the wedge. We can say that maximum height attained or climbed by the particle is equal to h, which we are supposed to find out. So as such there is no external force, so we can use the conservation of momentum of initial position and final position. You can say by conservation of momentum, initial momentum will be mass particle m with velocity v, wedge is having a velocity of 0, is equal to, both are moving with the same velocity, so we can say this is m plus 4m multiplied v prime, and this will be 0, so m cancels out throughout, therefore we can say that v prime is equal to v by 5. Let us call this equation number 1. So we said that the maximum height climbed by the particle is given as h. So we can use conservation of energy. conservation energy. Initial position energy will be equal to final position energy. So in the initial condition, only particle m is moving with the velocity v, so it is going to have only kinetic energy. So it will be half m v square plus wedge is stationary 0, and now the wedge is moving with the velocity of v prime, so this will be half 4m v prime square plus the particle is moving with the velocity v prime, so this will be half m v prime square, and plus the particle is also having the potential energy, so that will be equal to mgh. So we can solve this further. So from here this m cancels out throughout, and we get this as half v square is equal to half v prime square plus half 4 v prime square plus gh, and this we can also write further as v square is equal to, we have 1 plus 4, and this will be v prime square plus 2gh. So we can say, that our v square is equal to 5 v prime square plus 2gh. Now we know the relation between v prime and v in equation 1, so we can say using equation 1 we get this will be equal to v square is equal to 5, and this will be v by 5 whole square plus 2gh. So which basically means this will be equal to v square by 5 plus 2gh, and combining the like terms we get v square 1 minus 1 upon 5 is equal to 2gh. From here we can say this will be equal to 4 by 5 v square is equal to 2gh, or we are supposed to find out maximum height. So we can say our height h will be equal to 4 v square divided by 5 multiplied by 2g, and this cancels out, therefore we get h is equal to 2v square upon 5g. So this is the maximum height attained by the particle. This is the maximum height climbed by the particle, or we can say for mass m. Therefore, from the options you can say option number C is the correct option. Therefore, we can say that option C is correct. So this completes the question. Thank you.